Hi, I'm Chen-Hao. Today I'm going to introduce our recent work beyond mask and unmasked discrete diffusion models via partial masking. The goal of this work is to improve mask diffusion models, which is a new type of discrete generator that can be used to generate text, image, or anything that can be tokenized. In this framework, we have forward and reverse diffusion processes. The forward process is controlled by a scheduling function alpha t, which determines the probability of keeping the value of a token. In the reverse process, we train a model to predict the missing token, and we can use Bayesian's rule to derive the probability of flipping the token to the prediction. The loss function can be written as a variation of upper bound, which is a cross-entropy loss weighted by the scheduling function. Compared to autoregressive model, mask diffusion model typically have inferior performance. However, in this work, we show that our proposed MDM prime can outperform autoregressive model. We found that mask diffusion process is actually very inefficient. As you can see from the plot, there are around 37% of the sampling steps are idle. And the idle steps here means that the sequence remains the same in two consecutive sampling steps, which induce a lot of redundant compute. Therefore, we want to redefine the diffusion process so as to have better model utilization. We first encode each token into a sequence of subtokens and then independently mask them. That give us intermediate states that interpolate between unmasked and masked states. The diffusion process defined in the subtoken space therefore enables a more fine-grained transition from the masked token to the final clean token. It can effectively increase the model utilization, and this is an illustrated example. As for implementation, because base-bin encoding is an invariable transformation, so the loss function remains the same. That basically says that we can reuse the original training process to update our NDM prime model. As for architectural design, we keep the original decoder to model the joint distribution of subtokens. Also, we modify the encoder to accept subtoken inputs. We found that the performance improvement is correlated with the token granularity. Also, it is inverse proportional to the idle state ratio. NDM prime achieves superior performance on open web text pre-training, zero-shot textual benchmarks, and image generation benchmarks. Thank you, and you can find more information on our GitHub and project website.